We're going to start with just a simple patch of dirt, but by the end of this, we'll have turned it into some seriously precise project data. So welcome to our explainer on excavation estimation. It's that invisible but absolutely critical first step that can honestly make or break a whole construction project.
It sounds almost like a joke, right? How much does it really cost to dig a hole? But the answer is this fascinating mix of geology, geometry, and economics. And believe me, getting that answer right is fundamental to any successful build.
Yet this is about so much more than just moving dirt around. A tiny miscalculation can kick off huge cost overruns, it can push a project weeks, maybe even months behind schedule, and it can even create dangerously unstable ground. The bottom line is, accurate estimation is the bedrock of a project's financial success and safety.
So here's how we're going to break it all down for you. We'll start with why this is all so important. Then we'll get into the actual science of soil, which is super interesting. After that, we'll dive into calculating the volume, how to document it like a pro, and finally, how to turn all that data into a real-world budget.
Okay, so let's kick things off with the stakes. Because a seemingly small error in how much earth you think you have can set off this disastrous domino effect, threatening the entire project right from day one.
So when your numbers are off, you end up with one of two problems: way too much dirt or not nearly enough. That means you're suddenly paying for extra trucks and disposal sites you didn't budget for, or you're scrambling to find more fill, and both of those just blow up the budget. Unexpected volumes bring everything to a halt, causing these crazy expensive delays. This can even lead to things like slopes that don't meet the design specs, environmental fines, and most importantly, serious safety hazards on site.
All right, now before we can even think about calculating anything, we have to understand the material we're working with. And what's really fascinating here is that soil actually changes its volume depending on what state it's in. It's not a constant.
Our starting point for everything is something called bank volume. Just think of this as the soil in its original, natural, tightly packed state, exactly as it sits in the ground. Every single calculation we make starts from this one baseline number.
Now here's where it gets really interesting and where a lot of mistakes happen. As soon as you dig up that bank volume soil, it breaks apart, right? And air gets in between all the particles. This is called swell. All of a sudden, 100 cubic meters of dense soil in the ground might take up 125 cubic meters in a dump truck. Then, when you take that loose soil and use it as fill, you have to compact it, squeezing all that air back out. That's shrinkage, and its final volume might end up being even less than the original 100 cubic meters you started with. Ignoring this dynamic duo of swell and shrinkage is one of the most common and most costly mistakes you can make.
And this brings us to the two main jobs we're measuring: cut and fill. A cut is just what it sounds like. It's where we excavate soil, we cut it out. A fill is where we build up the ground, like for an embankment. A lot of projects, like a road on a hillside, will actually have both. You cut from the high side, and then you use that exact same material to fill the low side.
Okay, let's get to the heart of it. How do we actually calculate the volume for a simple excavation, like, say, a building foundation?
Well, it all starts with what's called a cross-section. Now, for more complex shapes like a road or a trench with sloped sides, you'd use some geometry. You'd use variables like the base width and the depth to find the area of this one slice. Then you'd use that area to calculate the total volume along the entire length. But to keep things simple for now, let's just start with a basic rectangle.
For a simple rectangular hole, the math is pretty straightforward. The volume is simply the length times the width times the depth. So in this example, a foundation that's 12 meters long, 8 meters wide, and 3 meters deep gives us a bank volume of 288 cubic meters. That's our starting number, before we even think about applying factors for swell or shrinkage. But look, raw calculations are really just one piece of the puzzle. In any professional setting, this data has to be meticulously organized into a document that everyone on the project, from the architect to the contractor, can understand and use.
This right here is what's called a measurement sheet. It's the standard way to record all your calculations. As you can see, each item is listed out separately, from the initial digging to the concrete for the foundation bed. It lists the number of items, all their dimensions, and then that final calculated quantity. This creates a really clear, transparent paper trail of exactly how the volumes were determined.
So now we have our quantities. They're all neatly organized. But how do we turn a volume of dirt into an actual dollar amount? Well, that is the job of the Bill of Quantities, or as everyone calls it, the BOQ.
Think of the BOQ as the master rulebook for costing out the project. It takes all the info from those measurement sheets and lists every single work item with a detailed description and a precise quantity. This is what allows different contractors to submit bids based on the exact same scope of work, which ensures the whole bidding process is fair and competitive.
So how do contractors actually put a price on each item in that BOQ? Well, they calculate something called a unit rate. And this rate, say per cubic meter of excavation, isn't just some number they pull out of thin air. No, it's carefully built by adding up all the little costs. You've got your labor, your machinery rental and fuel, and all the project overheads like site supervision and transport.
And the BOQ's job isn't over once the contract is signed, not by a long shot. As this quote from the Royal Institution of Chartered Surveyors makes really clear, it becomes this powerful tool for cost control. All through the project, the client's cost manager can track the actual work being done against the quantities in the BOQ, making sure the project stays on budget.
All of this leaves us with a final question to think about. In modern construction, what's really the more important tool for a successful excavation? Is it the shovel or is it the spreadsheet? Because as we've seen, you can't move dirt without the shovel, for sure. But it's the data, the calculations, and all the careful planning in the spreadsheet that truly lays the foundation for success.